In this video we're going to be plotting some points using a certain type of technology. The product's called Desmos or Desmos. Some people say it's an online or app-based graphing software, plus it does a lot of other things as well, but I won't go into that now. We're going to do this thing called regression, which we're going to use with technology, and it's going to help us make sense of points that appear to be scattered. We're also going to use Excel as well, and we're going to do it with trigonometric functions. We're going to use a transformation of y equals sine x, and in fact we're going to look at the parameters a, b, c and d, and we've got a times sine bx plus c plus d. But of course, as we've seen, that can be written in different ways. There's variations in that, which we go into in other videos. Let's have a look. If we're given a lot of data, let's see what we can use as far as technology to help us make sense of it. So you can see here in Excel we've got some data, and we want to plot this. And so we've got column A, and that's going to be, let's call that our X. So I'm just going to insert a header there. That's going to be our X, and that's going to be our Y, just to keep things simple. And we've got some data there. X values go from 0 to 20. Y values, well, they're all different values, positive and negative, and they're fairly small. So let's see, if we're trying to test to see if it makes sense as a trig function, like a sine or a cos, this is what we do. So we've got to grab the data first. So don't take the headers, but take all the data. So you hold your left cursor key or left mouse button down and highlight both columns, and Control C to copy, or hit copy, and then have Desmos open. It's best if you have an account, but you click in an empty cell there, and then you go Control V or paste, and you watch this. It recognizes that the data forms a table. It's very clever. There you go. So it automatically understands from Excel that it's a table, and it saves you a lot of time entering it in there like that. So you've got that there, and you can see it looks like a swarm of bees, and green bees, or maybe they're green peas, but it looks random, doesn't it? But if we do want to test that it's a cos or a sine function, whichever one you're doing, I think I might change that to, that said cos down there, I'm going to change that to sine. And you can see that what we've got, take a close look at that, that says y sub 1, little subscript. Now you've got to give it a number, so when you enter that in, you enter in not just y, but you enter in y and just hit 1, and it does that there. Okay, so why is it called y1? But if you go up to the top there, whoop, that needs to be renamed y1 to match it. Okay, and this one's going to be called x1. They've got it, doesn't matter what the number is, it's just a name, but they've got to be matching, alright? Because you can see down here this one says x1. Now you type in y and the tilde button, that's what that wavy line is just to the left of the cursor. And if you go next on your keypad to the left of the 1 key and you go shift, you'll get the tilde, which is a mathematical symbol. And that means regression. That means approximate this line with a formula. And you go, okay, I'll do that. So enter that in, enter in a times sine, open brackets there, b, open brackets again, x1 plus c, double close brackets plus d. And you've already seen on the screen that it sort of says, yeah, that is I reckon I can make a line of best fit trig function out of that. And this one happens to be a very good line of best fit. They're not always that good. But you can see there that the dots are consistent with the pattern of a sine function, and it gives you some things there. It gives you an a value for the what basically is the amplitude. It gives us a b value, a c value, and a d value, and therefore you can write the equation. Okay, you'd write this one as you just pretty much take all those values there. Alright, so I might as well do that. Okay, so you can see that this particular function would be y equals 1.2 sine, now b is 1, so I'm not going to write it. Well, yes I will. Alright, x plus, okay, now what's c? It's negative 2.0, so I've just changed the color there and I've put in the c value and close brackets twice plus d, so it's plus negative 0.7. Let's tidy that up because it's still a little bit ick. So did you know ick was a mathematical term? So we can get rid of that 1 there, it does nothing. Timesing by 1 does nothing. So 1.2 sine x, now plus a negative is minus, x minus 2.04, and you need the single brackets here. Instead of plus negative 0.7, we can go minus 0.7. So that is an equation that seems to suit the lines, and we use technology to support us. Now, technology alone is often not enough for a maths task you might be doing in high school, but it can verify, so it can support your answer or show that you're on the right track. So it's like checking, verifying. So it won't take the place of doing the maths, but it'll be of a lot of help, and it can actually help you verify to show that your answer is reasonable. Okay, so another thing, this is an optional thing, very optional, but some people aspire to higher things. That's called the coefficient of determination. Coefficient of determination. It's called r squared, and the closer to 1 that is, the closer the mapped or the regressed line or curve fits the points. Now that is a perfect correlation because, look, I rigged this one, but you'll get data that doesn't fit models as well, and you might get an r squared of lower values like 0.7, and that would be pretty ordinary. You might get something like r squared equals 0.991, which would be strong, and things like that. Okay, that's optional, but it gives you a sign. If it's close to 1, it's looking good. So that's how you use trig regression using Desmos and Excel.